Welcome to IIT PAL program. Today we will discuss oxidation of aldehydes and ketones. So, aldehydes has been found to differ with ketones in oxidation. So, first we will discuss oxidation of aldehydes. And either strong oxidizing agents like KMnO4 or chromic acid, also mild oxidizing agent that we will discuss little bit later. So, in aldehydes there the carbon atom is retained, but we will now see in ketones it slightly differs. So, if C1 C2 bond breakage, then these two acid will form, and it is important that ketones in ketone oxidation the bond breaking happens. Also possibilities is another possibility is this one. And here C2 C3 bond breakage. Some examples: if you oxidize acetophenone, then you get benzoic acid plus formic acid. Now, we will discuss how you differentiate aldehydes and ketones. And two tests can be done where aldehydes will respond and ketones will not respond. First is the tolerance test, another is Fehling test. So, first we will discuss tolerance test. So, what is tolerance reagent? No, it is ammoniacal silver nitrate. So, this reaction is done under basic medium. So, if aldehydes are treated with ammoniacal silver nitrate and then this silver mirror can be seen and aldehydes will respond. So, what is Fehling test? Fehling test plus you will get some water 3 molecules. So, as you know this cupric solution generally cupric sulphate is blue and cupric oxide you will get red brown. And another important thing that only aliphatic aldehydes. So, tolerance test generally both aldehydes both aromatic and aliphatic aldehydes will respond, but here only aliphatic aldehydes. And tolerance Fehling's reagent is basically two solution which is called Fehling A it is It is mixture of phenyl A and B, and generally before the reaction you have to mix phenyl A and B in equimolar quantities, and then you have to treat with aldehydes. So, it is alkaline generally. So, what is the, if you mix them, what will it form? So, bidentate complex of tartarate is formed. And which is blue in color. Now, we will discuss one special reaction, which is haloform reaction. And this name comes from, because in this reaction a haloform like iodoform will generate. So, what is the reaction? So, aldehydes and ketones having so, the oxidizing agent is sodium hypohalite, and the product is so carboxylic acid having one less carbon atom, and that carbon atom goes to the haloform, and haloform so methyl group attached to carbonyl, we can think that this group should be present. So, only aldehyde that can give taste is the acetaldehyde, because if you put any other except hydrogen, then it becomes ketone. Also, it has been observed that this kind of compound, the alcohols which are oxidized in situ to the ketone, can also respond to the haloform test. So, what is the test now? We will see. which is generated by sodium hydroxide plus halogen. So, you get sodium hypohalite and then you get and if it is X is equal to iodine, then you get CHI3 and this is iodoform, this is called iodoform and you get yellow precipitate. And this is then test also that compound ketones and aldehydes having a COCH3 group, when you treat with sodium hypohalite or sodium hypoiodide, you get this yellow precipitate. So, we can discuss example. Suppose if you treat with acetophenone and discuss also the mechanism. So, if you treat acetophenone with base, what will happen? This we will discuss little later now also, that CH acidity. So, this carbanion is formed and which can be resonance stabilized by Reynolds. And then suppose if it is iodine, then it reacts with iodine and then you get this one. And then repetition so, all three hydrogen is replaced by iodine and then the base is present. So, then it will hydrolyzed. So, base if attacks you get this one and since this is quite stabilized now with 3 iodine. So, you get this one benzoic acid and minus C minus I3 and which, because this strong acid it will protonate the iodoform and you get the precipitation of iodoform in the reaction. So, this is base mediated reaction. So, we will discuss some more examples which concern the acidity of the alpha hydrogen. So, acidity of alpha hydrogen we will discuss a little bit now. So, carbonyl compounds which have alpha hydrogen it can be like this also, that hydrogen. So, this hydrogen is acidic and it is due to two reasons. One is the electron withdrawing carbonyl group is there. So, which is present also alpha position of the alpha CH. Also, if you deprotonate it by base, just in the Haloform reaction we have seen that you get resonance stabilization. So, resonance stabilization. Stabilization of the carbon ion. And this is important because when the delocalization of charge happens, then it gets more stabilized. Now, we will discuss some reactions which concerns the acidity of alpha hydrogen, and first one is aldol condensation. Aldol reaction. So, aldehydes and ketones which have alpha hydrogen So, if they are treated with dilute alkali, that is weak base a little bit, dilute alkali, then beta hydroxy carbonyl compound, beta hydroxy aldehyde that is called aldol, or beta hydroxy ketone, which is called ketone, is formed. And this is called aldol reaction. So, we will discuss example little bit. So, suppose if you treat acetaldehyde dilute OH minus, then what will happen? So, this is beta hydroxy aldehyde and this is actually aldol product, and if you heat it, then the dehydration will happen and you get alpha beta unsaturated aldehyde, and that reaction then it will be called aldol condensation. So, if you only get this one, then it is called aldol addition, but if you heat it and elimination of water happens and you get alpha beta unsaturated aldehyde, then it is called aldol condensation reaction. Similarly, ketone also, like acetone, this is mild base barium hydroxide, you get and this ketones also sometimes is the general term, the aldol is used also. So, this is addition product and If you heat, then you get the alpha beta unsaturated. And so the aldol common term is used for both aldehydes and ketones. Ketol is not so much used, so aldol condensation is used. And here you see only same molecule is used, 2 equivalent, and that is called homoaldol also. And we will discuss little bit now cross aldol reaction. Cross aldol reaction means between two different aldehydes, two different ketones. Okay. And when both aldehydes, suppose both aldehydes have alpha hydrogen, then there is possibility of 4 products. Like if you treat acetaldehyde and propanaldehyde, so you see both as alpha hydrogen, and that means there will be the 4 possibilities, the homoaldol, and then cross aldol, and then in the cross aldol one will be donor acceptor, another case another will be donor acceptor. So, we will see what will be the aldol dehydration products. So, this is when this is called homoaldol condensation. This is homoaldol condensation, and another 2 products will be formed from cross aldol. So, what is that? So, you can get this product. So, when acetaldehyde will be acceptor and propanaldehyde is donor, another case and in this case acetaldehyde is the donor and this is acceptor. So, these are cross aldol products. So, as you can see, as you can guess that if the number of CH number of compounds where the CH alpha CH is there, then there is a mixture of products. But if one of them does not have alpha CH, then you can get selectively one product, like reaction between acetophenone and benzaldehyde. So, acetophenone has alpha, this alpha CH is there, but in benzaldehyde there is no alpha hydrogen. Actually, there is no alpha carbon to this side, so there is no alpha hydrogen. So, what happens if you treat with base? This is a donor and this is acceptor. So, if you heat it, so these parts come from acetophenone and this is benzaldehyde. So, if you treat with base and then heat it, so it is aldol condensation product. A similar reaction can be thought with ester. If you treat with base and then heat, you get (1,3-ketone), 1,3-diketone. So, the enolate reacts and ethanol is eliminated. So, you get this one and this called Claisen condensation. So, aldol condensation is the reaction of carbonyl compounds where alpha hydrogen is present. Now, there is another reaction where aldehydes respond and it does not have alpha hydrogens. And that is called Cannizzaro reaction. So, who will respond? Aldehydes, no alpha hydrogen, and you need strong base. So, compared to aldol reaction where mild base is sufficient, but here in this case you need strong base. And in this reaction what happens? Gets oxidized to another molecule gets reduced to alcohol. So, this kind of reaction is called disproportionation reaction. So, this is disproportionation. So, we will discuss examples. like formaldehyde. Formaldehyde does not have any alpha carbon, so there is no question of alpha hydrogen. Like concentrated KOH, and you have to heat it, then you get formate, potassium formate, that is the acid actually, and then you get methanol. Similarly, benzaldehyde, also we saw that in the aldol reaction it accepts as donor and it does not have any alpha hydrogen. So, 2 molecules of benzaldehyde reacts and if you heat it, so one molecule gets oxidized to the benzoic acid and here it is salt now, and another molecule gets reduced to benzyl alcohol. We will discuss cross Cannizzaro reaction, and cross Cannizzaro reaction is generally defined aldehydes without alpha hydrogen. So, it has been found if formaldehyde so, this is important. When aldehyde does not have alpha hydrogen, they are non-enolizable. Then what happened? Formic acid is formed, and alcohol of this aldehyde gets generated. So, selectively the formaldehyde gets oxidized, but the other non-eligible aldehyde gets reduced. So, why is that? That we will see now, and also we will discuss the mechanism of Cannizzaro also. So, what happens? The formaldehyde does not have any other group, R group. That is why the electrophilicity of formaldehyde is more compared to other aldehydes. So, if you treat formaldehyde with hydroxide, in presence of other aldehydes, the hydroxide and selectively goes to the formaldehyde, because it is more electrophilic. More electrophilic. And then suppose if you treat with benzaldehyde, this is the important step here. Since this is acidic, so it will deprotonate its proton and you get the benzyl alcohol. After acid treatment, I am sorry that I forgot to remove the oxidation term in some slides, because some reactions are not oxidation reactions. Now, we will discuss aldehydes application and uses. So, formaldehyde is disinfectant and it generally kills almost all bacteria, that is why it is used as biological preservative. Benzaldehyde also has nice almond flavor, and that is why it is used as flavor compound in many foods like ice cream, candy, etc. Similarly, cinnamaldehyde has also cinnamon flavor. Citral also used as antiseptic, also as perfumes, and vanillin, that is why it drawn structure in the first class, as also important compound and it has vanilla flavor. And we conclude here. Thank you.